Okay, let's start with the first problem. It says, what is the radian measure of an angle whose degree measure is 72 degrees? A simple question. Write this down. 72 degrees times pi over 180 degrees. You're expected to simplify, of course. And it looks like, degrees would cancel, and you could divide both top and bottom by 36. What would you get? You would get 2 pi, because 36 goes into 72 twice. And 36 goes into 180 5 times. I consider this to be a simple question. All right, let's go to the next one. All right, it says find the values of sine of theta, cosine of theta, and tan of theta for the angle that's in the standard position with the terminal side having the point minus 12.5. All right, so I'll put my xy axis down, or abscissa ordinate, and kind of ballpark where this would be. And this is somewhere over here. All right, this is the terminal side. There's a point on it, and that point is going to be minus 12, comma 5. And this is the angle theta, and we're in standard position. And what do I know? Well, I know x is minus 12. I know y is 5. And I know that r squared is equal to x squared plus y squared. So r squared, x squared, rather simple to do, is 144, and y squared is 25. So r squared is equal to 169. So really r is actually equal to plus or minus the root of 169, which is 13. Now r is a positive number. We're talking about a circle over here. So the r for this problem over here is 13. Let's write the answers down now. So sine of theta, you would need to know the definition of that, by the way. That's going to be the y-coordinate, which is 5, over r, which is 13. The cosine of theta is the x-coordinate, which is going to be minus 12, over r, which is 13. And the tangent of theta is going to be the y-coordinate over the x-coordinate, so it's 5 over minus 12. And that's just not a polite way to write that problem, so I'll write it as minus 5/12. All right? So, again, I see it as being, if you knew the definitions of that issue, it's a simple problem. All right, sine, again, the sine of theta is 5/13. The cosine of theta is minus 12/13. And just give me 1 second here. And the tan of theta is minus 5/12. Okay, let's go on to the next question. Okay, this one goes back to something that we studied earlier, which is the conic sections. So I'm going to kind of write this in standard form because they are asking about the vertex of it. So let's write this down. This is going to be x minus 1 equals y squared plus 4y. I'm going to complete the square. How do I do that? Well, it's written pretty nicely. Half the 4 is 2. When you square that, you get 4. So what I need to do is I need to add 4 to both sides. Well, if you add 4 to the left side, you would get x plus 3. And if I add 4 to the right side, I would get this. So I get x plus 3 equals y plus 2 squared. Well, it's in the form I like. And why is that? I can put the vertex down now, and then we'll answer the question in a moment. And the vertex is, let's see, the x would be minus 3, and the y-coordinate would be minus 2. Again, I want to emphasize that part of this is just reading and what you've read. They want to know the value of k, and the value of k over here, again, this is the point, that's the vertex. The value of k is actually minus 2. All right? That's not so bad. Again, if you understood the question and you studied the material that we provided to you during the course, this should be a rather simple question to answer. Let's go to the next question. Okay, so this one, again, you would need to know simple, reference triangles. And the reference triangles I would need to know, I'll put this down for you. You need to know a 30, 60, 90. Let's see, that would be 1, 2, root 3. And I would also need to know a 45, 45, 90. And again, I'm not saying I'm drawing these terribly accurate, but it's enough for me to abstract the problem. What's it going to be? 1, 1, root 2. All right, so let's write this down. 2, well, the sine of 30 degrees is going to be 1/2. Now, you should know the secant of 135. It's in the second quadrant. It's going to be negative, and the reference there is 45 degrees. So it's going to be minus root 2. Plus, well, the tan of 135, I'm going to square that, of course. What would that be? That would actually be minus 1. Let's go through the arithmetic. You're going to get minus root 2 here, and plus 1. And I'll write this as 1 minus the root of 2. Again, a relatively simple question if you understand the question. Now, of course, if you don't understand the questions, nothing's going to be simple. So we got through quite a few problems there. It was number 4. And now we'll go to number 5, all right? So number 5, next question. This one, I'm always big on, not memorizing too much, but trying to visualize what they're asking for. So I'm going to put my little picture down here. I'm not going to say it's going to be terribly accurate, but it's enough for me to understand the question. They say it's an ellipse. They tell me the foci are at 0, minus 3. And put this over here, 1, 2, 3, right there. That's one foci. The other foci is minus 6. Let's see, 1, 2, 3, 4, 5, 6, minus 3. All right. I think I know the center now, and the center is going to be the dead point between there. So I think I can write the center down. Let me write this down for you. And what's that going to be? And again, you don't need a picture to do that. You could just add those points together and divide by 2. You get minus 3, comma, minus 3. That's the center. All right. So someone says, why do you need that? I need that because I know what equation of ellipse looks like, and it depends on the center. What's going to look like now? X minus a minus 3. That's plus 3 squared over something. We'll get to that later. Plus y minus a minus 3, which is y plus 3 squared. And that's equal to 1. Just something I got to figure out now. And what do they tell me reading it? They tell me the major axis is a length of 10, which means I got to go in 5 units from the center. So there's a point over here. It's the major axis. And what's that point going to be? Let's think about it. If this is minus 3, minus 3, and then go 5 points in, this would be 2 minus 3. All right? Put a point over here. And again, I'm not saying it's terribly accurately drawn. It doesn't have to be. And it's still going to be minus 3 for the y coordinate. And I'm going 5 units to the left of minus 3, which would be minus 8. Now, someone says, why do you need that? I need that to figure out what the divisor is. And what I'm going to do is, take this point here, plug it in, and I'll figure out the bottom point, all right? The bottom value, I mean. And I'll just plug it in. What do you get? You would get 5 squared. Again, I'm plugging this point in. 2 plus 3 is 5. 5 squared is 25, of course. Plus, this would turn out to be 0. And that equals 1. Now, of course, I don't know what that is, but I do know what this is now. This has to be 5 squared, right? It has to be 5 squared. I'll put that down, 25. All right? Now, the next thing, you may not be able to remember this. It's fine if you can't. But it's something to do with the c. All right? So what's that going to be? Well, the c squared, I'll put this down as b squared now, is going to be a squared minus the b squared. C squared. Oh, I'm sorry, I know what c is. What's c? It's this distance over here. And what's that distance? That distance is actually 3. Let me get my eraser out. Go back to this. So again, the c is 3. I'll write this over here. That's the distance, by the way, between the center and the foci. It's 3 units. The c squared is 9. The a squared is 25 minus the b squared. And what do you get there? B squared would actually equal 16 then. Let me get my eraser out, and I'll kind of erase this b squared now and put it down. 16. All right, let's see if we've answered the question. I'll read it to you if I write an equation of ellipse. I just did that. There's no reason to simplify that, but that is the equation of the ellipse. And the equation of the ellipse, again, x plus 3 quantity squared over 25 plus y plus 3 quantity squared over 16 is equal to the number 1. All right, that's number 5. Let's go to number 6. Number 6, again, really going back to the beginning of the semester, and this is a relationship S equals R theta. Remember, theta needs to be in radian measure, and they said the central angle is 30 degrees. Let me write this down for you. That's pi over 180 to convert it to radian, and that's going to be pi over 6 now. So I know what the theta is, and this is the theta in the problem now. All right, and it says that, circular arc, well, they tell me the arc now, that's the arc length, is 6 meters. What do they want to know? What's the radius? Well, I'll write this down. So S is 6 meters. I don't know the R. And the theta is pi over 6. A relatively simple equation to solve. You can get 36 meters over pi would be equal to R. So what's the answer over there? What's the length of the radius? The length of the radius is 36 divided by pi meters. All right. Again, a simple question, if you knew what the relationship was between the arc length, the radius, and the angle measured in radians is. If you didn't, it wouldn't be a simple question. All right, let's go to the next one. Number 7, again, for some students, they look at this and wonder what do you want to do with this one? They want you to get the range of it. So get the range of it. I got an idea what this thing looks like. And I always say to get range, this goes back to 119, you really should visualize the problem. And the root of x, which is when you're above the or equal to 0, would look like this over here. That's what it looks like. All right, starts there and it goes off forever. It keeps going up and up and up and up. Now, what does the sine function look like? Well, it's a wave, and it's got to be below the 0. So what does it look like? It looks like this over here. Again, it's just a rough picture of it. Right, it goes on forever. Now, by the way, it hits the bottom over here. What's the bottom going to be? -3. Why is that? That's the amplitude of that wave. So what's the range of this thing over here? Relatively simple. It bottoms out at -3, and it goes off to infinity. That one's done. That was number 7. All right, let me keep going, and I guess I'll go to number 8. Number 8 says rewrite this thing. It's a circle. That's an equation of a circle. And I want to put the polar form down. So it goes back a little ways in the notes when we did the parametrics and the polar. And I got relationships over here. For example, x is equal to r, which is the radius cosine theta. That really goes back to day 1 of the class, by the way. And y is equal to r sine theta. Now, you realize when we get to polar coordinates that r is not restricted to be a positive number. But they're doing that here. I just noticed that right over here, that they're restricting it. They're saying r is a positive number. We'll talk about that in a moment, though. But right now, I'm just going to plug it in. I'm going to plug it in, well, x squared. What's x squared? X squared is actually equal to, let me write this down for you, r squared times cosine squared. And y squared is equal to r squared times sine squared. So x squared plus y squared is equal to 64. Well, let's write this down. What do you get? R squared cosine squared theta plus r squared sine squared theta. And that is equal to 64. Now, of course, I'm going to simplify a tiny little bit. R squared comes out. I'm going to factor it out. And then as soon as I do that, I notice that there's a Pythagorean identity. And that Pythagorean identity is probably the most famous one we've got. It's just simply equal to the number 1. So what do I get? I get r squared is equal to 64. Now, in truth, what's r? R could be equal to plus or minus 8. However, what did they tell me? They told me r is a positive number. So the answer over here is r must be equal to 8. And that's an equation of a circle with radius 8 centered at the origin. All right, that's problem number 8. Let's move on to problem number 9 now. All right. Now, granted, they may look at this and say, I don't remember how to do that. And the thing is, it's going to happen to you. You're going to be given questions you can't remember, particularly on exams, and you avoid those questions then. You don't spend time on things you can't answer. But I don't think it's a difficult question, but again, you may disagree with that. The first thing I would do is I'd kind of visualize the tangent function in the invertible region. It's something like this over here, all right? And what do I know about this over here? I know there's a ratio, and that ratio would give me minus 5 over 2. So now I know the angle theta for this is between, what would it be between? For the tangent function, the angle would be between, let's write this down, let's see, minus 90 degrees and 0 degrees. I know that much. By the way, I don't know the angle. It's not a reference angle that I know. So what I need to do is I need to determine, the sine function, and this is, kind of difficult for students. They look at the sine function. The sine function, between minus 90 and 0 is over here. That's what it looks like, all right? So what do I know about it? I know the sine function's going to return a negative value. I know that much, all right? Again, we're dealing between the angle minus 90 degrees and 0, and you should have a rough idea that the sine function is certainly below the x-axis on that interval. I'm just going to put a reference triangle down now, and this is going to be my reference triangle, and my reference triangle is going to have an angle between 0 and 90 degrees. Let's put that down for you. Again, I don't know what the reference is, but I'll put the ratio down. What's it going to be? Well, for the tangent, it's 5 over 2. And how do I get the hypotenuse for that? Square the 5 is 25. Square the 2, which is 4. It's going to be root 29. And what's the sine of that reference angle? It would be 5 over root 29. And again, you may have to go back and review that material. That material is provided to you when we did the inverse functions. All right, that was number 9. Let's go to number 10. Number 10, again, my recommendation is just draw a picture of it. And kind of looking at it, reading it through. And again, reading is a really important skill set. And kind of reading it, I got ABC, there's a triangle, hypotenuse AB is 17. Let's put this down, the hypotenuse over here. Make a right triangle. Let's see, that's 17. And this is going to be A, B. And then they talk about the leg AC. Let's see how we're doing this, 15. All right, I think I can figure out, I think I don't know what the question is yet, but I can figure something out here. And what I want to figure out is I want to figure out what the length of BC is. And the way to do that, 17 squared. I'll write this down for you. Equals 15 squared plus, I'm just going to call this x for the time being, but I will erase it, x squared. That's 289. And this would be 225. And I'm going to subtract 225 from both sides. You're going to get 64 is x squared. And x would equal plus or minus 8. But really, I'm looking at a physical triangle, so it has to be 8. All right, so x has to be 8. Let me get my eraser out. Erase this over here. And I'm going to put the number 8 down now. All right. Numbers are working out pretty nice. This is, hopeful that your numbers do work out nice for you. What's the question, though? I believe the question is, this is number 10, right? I believe the question is, what's the cosine of the angle beta? Well, the angle beta is actually the angle ABC. So this is the angle beta. So the cosine of the angle beta is going to be what? It's going to be the adjacent side to that, which would be 8 over the hypotenuse, which is 17. And we're done. Let's go to the next question. All right, this one's an arithmetic series. We've studied this in the past, but again, you may have to go back and review that material. I gave you an example, and the example they give is 1, 5, 9, 13, 17, 4 units apart. It's clearly clear as day. But then they say if the first term of the arithmetic series is 3, let me write this over here, and the last term, well, I don't know what the last term is, but I know its value. Its value is 136. All right? They tell me the sum, Sn, is equal to 1,390. Now, not only have we derived the formula for this, but we've used it many times, and I'm hoping you can remember that. And what's that going to be? Well, Sn is going to be n, and it's going to be A1 plus AN over 2. Well, let me see if this gives me anything. So I'm going to say 1390. I don't know what n is. A1 is 3. and an is 136. And that's all over the number 2. I want to solve for n. It's going to be 1390 times 2. And 3 plus 136 is 139. So now I know what n is. It's a rather simple number, and it has to be. It's an integer. I should say a whole number at this point. Oh, that whole numbers are integers. And that would give me 20. All right? Now, someone says, is that what their question is? No, not really. Their question is, what's the first 3 terms? Well, I certainly know what the first term is. It's 3. But let's write this down. So A20, I know what n is now, is 136. And I know the nth term, I'll write this over here for you. It's another formula that we know, is going to be A1 plus n minus 1d. Well, what's A1? A1 is 3. What's n minus 1 is 19d. Right, I think I can figure out d. Now, someone says, why do you need d? So I can get the next term, the next term, the next term. It's going to be 133 equals 19d. And I bet d is going to turn out to be a nice number. And what numbers it turn out to be? Let's see. I'm going to say 7. Let's see, 70 and 63. Yeah, d is 7. So what's the first 3 terms? The first term is 3. I got to go up 7. That would be 10, and then 17. These are the first 3 terms. 3, 10, and 17. All right, let's go to number 12. And number 12, find the exact value of the sine of u plus v. Let me write this down. And that's going to be sine u, cosine v, plus sine v, cosine u. A lot of students often question, do you need to write things down to answer questions? And I would say that's probably what you want to be doing, is writing things down, not trying to stab in the dark at what the answers are. But what I'm going to do is I'm going to fill in what I know. And yes, I'm writing this down for a reason. And the sine of u, do I know what the sine of u is? I do. It's 7/25. Do I know the cosine of v? I do. It's minus 12/13. Now, these guys over here, I really don't know, but I do know the angles in the second quadrant, all right? So the sine of v is related to this over here, all right? Denominator would be 13. And how do I do that? Well, I've been doing this all semester long, right? So we know something about this, and what do we know about this? We know it's going to be a positive number in the second quadrant, the sine is anyway. And so it's going to be 13 squared equals, let's see, minus 12 squared, which I'll just put down minus 12 squared, plus the y coordinate squared, right? But again, I know the y is positive. 169, 144, plus y squared, 25 equals y squared. But again, the second quadrant, the y coordinate is a positive number, so it's got to be 5. Put this over here. Let's do the other one, and that's going to be something to do with this guy over here. Denominator is 25. And when I get there, it's a simple relationship. I get this. I get 25 squared. The number's kind of big though, right? But anyway, we'll talk about it. I'll get there. And then what do you get? You can get 7 squared plus the x squared now. And I know the x is negative, all right? So let me write this down as 25 squared minus 7 squared is equal to x squared. By the way, I don't mind you doing arithmetic. You do what you want to do, but I'm going to show you what I'm going to do over here. I'm going to do 25 minus 7, 25 plus 7 equals x squared. What's that going to give me? Let's see, 18, 32. There's a reason for me doing this, by the way. This can be 9 times 64, and that equals x squared. So what's x going to be equal to? Well, it is plus or minus, by the way. That's going to be 3 times 4. I'm sorry, 3 times 8. The square root of 9 is 3. The square root of 64 is 8. But I do know it's not plus or minus. It's only one of those. But again, second quadrant, the x has to be negative. So minus 24. All right. I know this seems like a painful thing for a lot of students, and that's arithmetic. So what I want to do is I want to do the arithmetic. 25 times 13, I'll do this on the side. That's 250. And 3 times 25 is 75. So what's going to give me? That's going to give me, let's see, 325, right? Well, that's done. That wasn't so bad. And what do I got to do now? I guess I got to do the top part, right? And I guess that's going to be some work, isn't it? And it's not much work, but I got to do the work nonetheless. Let's see, 7 times minus 12, that's minus 70, and minus 14, so minus 84. And then you're going to get minus, let's see, 120, right? Now, the policy at Essex is you're not supposed to use a calculator to do these things. I realize some students have a tough time at arithmetic, though. You should work on that. And that's minus 204. Do I make mistakes? All the time. All right, but that's not a bad question. I mean, some arithmetic involved, but it's not much arithmetic. So minus 204 over 325. Let's go to number 13. Number 13 is a vector problem. And again, you may not be able to remember vectors, and that's part of why you study for exams, so you can remember when you get to the exam. But it says the length of V is 8, and the direction is 30 degrees. So I'm going to kind of draw a picture of that. And 30 degrees, sort of like this over here. That's the vector. You know, the angle here is 30 degrees. And the length of that vector is 8 units. So I realize I've got a reference triangle. I'll put that down. 30 degrees. And let's see, we've done these many times before. So 1, 2, root 3. Right, but I want the length of that hypotenuse to be 8. So I can multiply everything by 4. All right, so I think I know my point here. The point here would be 4 root 3. This is the point, by the way, and 4. Whoops. What's the vector v going to be? Well, you could write it this way over here, 4 root 3, comma 4. But they want in terms of i's and j's. So it's going to be 4 root 3 vector I, that's a unit vector, plus 4j. All right, so 4 root 3i, the I vector, and then 4j. J is the j vector. All right, so that's number 13. Let's go to number 15. I'm sorry, 14 now. Did I say it right? This was 13. Yeah, we're going to 14. Okay. And again, looking at it, I want to be able to do that. And let's think about it. So I'm going to talk about the arc cosine's invertible region. I'm sorry, the cosine's invertible region, not arc cosine, but looks sort of like this over here. And that's between 0 degrees and 180. And what do I know about the sine function between that? Well, I know the sine function between that is definitely going to be a positive. Right, and this helps me a great deal. So what I'm going to do is I'm going to do a reference triangle. And the reference angle, I'm going to put this over here as a reference triangle. All right? And the cosine of that reference triangle has a ratio x, 1. And Pythagorean theorem, what's this going to be over here? And it's a reference triangle. This would be 1 minus x squared. And again, I know the cosine is going to be a positive. I know that much. So I'm not worried about this plus or minus business. So what do you get there? Well, cosecant's right at the sine, right? What would sine be? It would be that root over 1. So it's going to be reciprocal. What's that going to be? 1 over the root of 1 minus x squared. We're done with that. That's number 14. If you want to rationalize that, I wouldn't recommend it, though, but you could. Something you've done in Math 100. I don't recommend it, though. Let's go to 15. Find the magnitude and direction of this vector. Well, again, my recommendation is draw a picture. And again, a lot of students want to bypass this because it's too much writing, they say. Let's see, minus 3 root 3 and up 3. So something like this over here. This is the angle, or the direction of it. And kind of looking at it, it looks like simple. It really does. In other words, I know the reference over here, and I'm glad they gave me a very simple problem over here. So the reference for that one would be what? That would be 30 degrees, right? So what's the theta going to be? 150 degrees. All right. What's the magnitude of that? Let's write that down for you. Well, I got to square the components, right? So it's going to be 9 times 3, which is 27, plus 9, which is 36. Whoops, I had to put square root in that, didn't I? And that's going to be 6. So the magnitude is 6. And the, let me see if I did that right. 15. The magnitude is 6. I got that. The angle's 150. Let me put that in radian measure for you, though. By the way, I don't mind the degree measure. But let me put this, just in case students are wondering what the radian is on that one over there. Pi over 180 degrees, which would be what? I guess I'd divide by 30, right? 5 pi over 6. So again, you could either say 150 degrees or 5 pi over 6. And again, the magnitude is just 6. All right? So let's go to the next one. I'm going to number 16 now. Number 16, again, a weird question. I mean, it says, which of the following expressions? I don't have any expressions written down over there. But yeah, again, I'd visualize it. And if you visualize this, minus 225, it's going in this direction over. That's, minus 90, minus 180. I'd have to go 45 degrees more here. So this is minus 225 degrees. So there's a variety of answers you could write down over here. For example, the cosine of minus 225 degrees is the same thing as, well, I could do this angle instead, right? That's 135. So I could write down the cosine of 135 degrees. By the way, we could play this game all day long by just adding, 360 degrees to the number or taking away 360 degrees from the number. How about if I wanted the sign down? Well, I guess I could, do that, and I could do that forever as well. So maybe I could say, what could I say? Well, I want to get it to be, it's negative number, right? And where would the first one be for cosine? It'll be over here somewhere. So I'm going to say this is the same thing as sine of 225 degrees. Same thing. And again, you could play that game all day long by just adding 360 degrees to that as well. And you keep doing it over and over again. So there's a variety of answers that could be listed over there. It really could be. All right, again, you could write down the sine of 225 degrees plus 360 degrees k, where k is any integer. Again, k could be 0, could be 1, could be 2, could be 3, could be 4, minus 1, minus 2, minus 3, so forth and so on. Coterminal, so to speak. All right, that's number 16. All right, let's go to number 17. Number 17 for a lot of students is tricky, all right? And this has to do with the beginning of the course where we talked about cofunction identities. So let me write this one down for you. The cosine, let's see, we did cofunction identities, right? So the cosine of theta is the same thing as the sine of pi over 2 minus theta. Right? These are what's called cofunction identities. So let's see if we can write that down. So let's write this down. The cosine of 5 beta, that's a beta, plus pi over 12 is the same thing as the sine of pi over 2 minus that angle. So it's going to be minus 5 beta minus pi over 12. Right? I just did this part over here. And this is the same thing as this side, which is sine of 4 beta plus pi over 16. And by the way, this problem's a little trickier than you might think, but they do say it's an acute angle, which really does help me out a great deal, because this would keep repeating itself over and over again. Let's write this down. The arguments must be equal now, so pi over 2 minus 5 beta minus pi over 12 would be the same thing as 4 beta plus pi over 16. All right, I'm going to multiply both sides by 60. And you get 30 pi. Again, I'm multiplying by 60. It's the LCD. This is the LCD in the problem. Let's see, 300. Let's see, minus 5 pi. Let's see, 240. I'm multiplying by 60, beta, plus pi. Let's see what you get, 25 pi minus 300 beta, 240 beta plus pi. Wow, tough problem, huh? Let's see, 540 beta. And let's see, 24, right? And then I want to know what beta is. And wow, that looks like a tough one, doesn't it? Let's keep writing that down. 24 pi. Whoops, that's not 24 pi, is it? Over 540 is what beta is. That's certainly an acute angle. My recommendation is probably reduce it. And let's see if we can do that. I'm going to divide by 2. Let's see, 250, 270, right? I'm going to divide by 2 again. And then I'm going to divide by 3. So beta, in its simplest form, is 2 pi over 45. All right, let's keep moving forward. And let's do this one. All right, this one, number 18. If the cosine of theta is equal to 3x, then the tangent of theta squared. Well, let's write this down. It's nothing to do with squares, right? So cosine of theta is equal to 3x. Let's square both sides. What do you get? Cosine squared theta equals 9x squared. All right. And again, I want to point out that tangent squared of theta is equal to sine squared theta over cosine squared theta. And you should know by Pythagorean identities that the sine squared theta is actually just simply 1 minus cosine squared theta. And I think I have what I need. I'll write this down for you. It's 1 minus, what's cosine squared? 9x squared. 9x squared. By the way, I like the answer. I realize a lot of students or even teachers would write this differently. They'd write it as 1 over 9x squared minus 1. It's also a fine-looking answer. Again, the way you write these down is up to you. The bottom line, hopefully your teacher, whoever that teacher is able to recognize variance in the answers. But both of those answers are legitimate. All right? Let's keep going. I think I have 2 more to do. And number 19 is simplify. And the problem with simplification is, can you do it? And looking at this guy over here, let me write this one down for you. I like to write things in terms of sines and cosines. Maybe I went too far with that, didn't I? So cosine squared, that's already cosine, right? So I'm not going to worry about that too much. Minus sine squared. And this is going to be 1 minus, the tangent is going to be sine squared over cosine squared. I'm going to build this complex fraction away by multiplying top by the minor LCD. And what'd you get over there? You get cosine squared x minus sine squared x times cosine squared x. And what do you get on bottom? You'd get cosine squared x minus sine squared x. Well, although not always true, it's conditionally true, provided that this is not 0, that this would cancel off. And what would you be left off with? Cosine squared x. And that's the simplest form of it. That was what number was that? Number 19. Again, relatively simple question. Let's go to number 20. 20 is probably the easiest one on the exam, or the review sheet, I should say. And A compliment, again, if you can't remember that, it's understandable. I can't remember a lot of things too. As you age, you're going to start to forget more and more, even simple things, by the way. But that's the whole point of before you get to an exam, is to study. Now, people often question me, how much time do you put into study? That varies from student to student. Some students put in very little study time. And by the way, they've been conditioned to do so. And the reason they've been conditioned to do so is that what happens is, for a lot of students, is that they take an exam, everyone fails the exam, and teacher lowers standards, all right? Now, someone says, why do students typically fail exams? Poor preparation. There's no question about it. It's not because their brains are weak or something. It's just poor preparation. Now, of course, you might be in another scenario, and let's say you're in a very competitive environment where the teacher's actually trying to write questions that separate the very competitive environment out. They make the questions incredibly difficult. I don't see this as a difficult question, by the way. And the question is a complement. And the complement's going to be 90 degrees. I'll write this over here, minus that number. There's a problem now. And this number is written as a mixed number. So I have to write 90 degrees as a mixed number. And what's that going to be? 89 degrees, 59 minutes, and 60 seconds. And what am I going to subtract away? 18 degrees, 15 minutes, and 33 seconds. Yes, mistakes can happen. I got to do subtraction over here. What are you going to get? Let's see, 27. Pretty simple. No borrowing required, by the way. 15 from 49. Let's see, 4. Looks like 44, right? And that's going to be, let's see, 1 and 7. All right? That's the answer. All right? We're at the end now. Thank you for paying attention.